So I will get started. Hello, everyone, and welcome to today's webinar on simplifying ocean data management for offshore wind. Before we begin, a quick reminder, this session is being recorded and it will be available afterwards. And also, please feel free to ask any questions you may have through the chat feature. You will see somewhere around your screen because we will address those questions at the end during our Q&A session. So stay tuned for it. Now, I'm excited to introduce you to today's speakers. First, we have Jan Wendt, our CEO and co-founder of North.io, who will be sharing insights of the ocean data management world, market challenges, and how to address them with innovative solutions. And then we also have Simon van der Wolp, our product expert, who will provide a live demo of our platform along with practical examples. So I would say let's get started.
Perfect, Natalia.
So I will quickly make you the presenter. Over to you.
Perfect. Thank you very much for the introduction. So positively overwhelmed by the interest in the topic that we're addressing. So from already existing customers to new ones. So welcome you in here. So I would like to tell you a bit and give the introduction into the topic of how we see the future of geodata and ocean and underwater data management in offshore wind energy. So Natalia introduced already very shortly, but as you mentioned, I'm the CEO and co-founder. I have a degree in geography and geoinformatics. We have Simon van der Wolp, who is our solutions engineer, who will guide you also through the demonstration. And Natalia introduced herself already, and we are grateful that she's organizing the workshop here for us. But let's dive into it with a short introduction into who we are, because we see some also new faces, not only familiar ones. So North.io itself was founded by myself in 2011, dealing with the topic of how the upcoming web and cloud technology at this time could be transferred into the world of geospatial. In the meantime, we transferred into a really ocean big data specialists. Yeah? So we have geophysicists, we have cloud computing specialists, we have web developers all over the place. And in total, we are already 65 people. We are very proud that we are just got elected into the top 100 geospatial companies worldwide. And I think that shows also that ocean gets a different kind of attraction and will also get in the future. Why is this the case? And I think you are all here because we are all in this domain and we see that ocean is changing. Yeah? So there's on the one side, and I think you can call it in some way industrialization. So we are building infrastructures in our oceans. In this case, we are focusing particularly in offshore wind, but it's just one part of the infrastructures that are connecting our world, that are forming the energy transition. So systems are getting in there, structures are getting in there, and they need to be data driven in some way as well. We see on the other side autonomous systems coming up. Yeah? So surveys are more and more done with autonomous systems. They are getting cheaper. We see data pressure on all sides. Yeah? So more usage, more autonomous systems, more sensors. And on the other side, we also see the first glimpse of connectivity, yeah, being at the Starlinks of the world, existing mobile structures that are placed in wind farms. So it's forming a total new different world also of introducing new ways of technology to deal with the complexities that are coming from it. And what are the challenges that probably also all of you are facing? That's why we are also having this webinar today. So there is an ever increasing amount of data, and it will increase in the future even more. I think that's clear. It's in all different domains, but also I think our domain, ocean, is very particular present in this data growth. We see also a complexity in file formats. Yeah? So the standardization in the ocean data and underwater domain did not really progress that fast as the sensor generation and the vendors are progressing. So we have a very big variety of complex files and formats. We see also problems of finding data. Yeah? So what does my organization have in terms of underwater data? It's actually a very easy question, but I think it's very hard to solve because you have to find the right places where data is located. You have to find the right Excel lists. You have to know who actually acquired this data. So a very big challenge. What data do I have as an organization? Visualizing this data, as I mentioned already, we heard that there are a multitude of software tools that need to be used desktop-based actually for visualizing all these different kinds of data set in a smart way. Collaborating, how to collaborate when you are talking about very, very big data sets. And we are talking there about data sets ranging the tera and petabyte size. So how do you work in complex projects, complex ocean projects together with all your stakeholders? And in the end, what do we want from data? We want to derive information. So we have several challenges that we need to address and also that we need to address to be future ready. What did we do there? 4 years ago, we started to develop a total new technology, based on state-of-the-art cloud computing, big data, and AI, because this is technology that we are needing already today, but even more in the future of handling the complexity and the challenge of this amount of data. So this technology, we call it True Ocean. It's our platform technology, is able to manage really petabytes of ocean data. It can scale with your data. Very, very important. We are able, and this is also a very, very USP from us, we are able to ingest and to standardize raw sensor data. We can read multi-beam, side scan, seismics, and also geospatial data. We come to this at a bit later stage of the webinar. We are integrating big data technologies because in the end, we want automation. We want to make it simpler. We don't want to be the last bits and bytes expert and geophysicist in every domain. We want to use technology to help us be faster, be more efficient. And for sure, the technologies of AI and accelerated computing, they are taking over. We are cooperating, for example, with NVIDIA, how to bring these technologies, these big data and AI technologies into the field of ocean data and ocean data exploration. So how do you use actually in cooperation, in an industry, in an organization, our technology? So our technology is very important, is cloud agnostic. We can run it on every cloud in the world. Everyone who provides a virtualized environment, we can run a managed service. So if you are now a new customer and approaching us, we can set up actually an environment which is fully isolated, which is fully secure in a cloud provider of your choice. Very, very important so that you can be compliant also with your IT registrations and restrictions in your organization as well. What we also do for specific customers, it's more in the high security domain, maybe related to defense topics, private deployments. So we are also able to bring our technology up to a single server and deploy it actually in a private computing center, if this is the need as well. What are your benefits of using our technology? I think that's one of the main important questions to answer. So clear benefits is cost saving. We are step by step replacing tools in this very complex tool chain, and we are reducing overhead. And as you all know, this overhead with this data is getting bigger and bigger. Who has data? Who has to get it? In which way? How do we transfer it? So there are immense possibilities of cost savings with our technology. Efficiency increase. We are bringing automation into the flow. We will give you later some example how it looks like, but we are making raw data very fast accessible to actually all the uphold stakeholders in this whole data value chain that need to be addressed as well. Quality enhancements. Since we can read raw data, we can very fast access the quality of raw data and see if it's feasible actually. And this is something, hydrographic data is complex, and errors are made, errors are human, they are done also in acquiring data. With our technology, you can very fast get an understanding, is the quality met that we want to achieve, that we maybe contractually also agreed on. And optimization of collaboration, a very important part. Our whole idea of introducing cloud and web technologies is how do we collaborate? We live in a digital collaboration world, and this also needs to be reflected in the ocean sector as well. Giving you a small peek intro and preview on where we are heading. So we would today show you mainly the topic of data management and collaboration. So how to organize data, how to manage it, how to find data on really large scale. So this is already in production and productively used by our customers. What we are also doing already now, and we will introduce this to the big audience in Q1, is doing pilots in the whole topic of big data pre and post processing. So we are already working in pilots of processing sonar data, multi-beam data, point cloud data on scale. Scalability is here the key. With the cloud in the background, we can scale. In addition, we are already working on the first implementation of analytic and AI functionality like feature detection, a very classical topic, but feature detection on raw data sets, so that we can detect boulders, for example, or UXO topics. And what we are already in the conceptualization phase, also with existing customers already, how do data marketplaces look like in the future? So where do I buy data? How do I actually acquire data? So imagine an eBay of ocean data. So where I as an organization go and I don't have to contract a surveyor, but we already know in this area that we have 5 surveyors who created qualitatively high data, and we just buy it via the platform. So this is the vision where we are heading with this technology. But all of the base is built in the topic of data management, collaboration, and understanding raw sensor data. Regarding data formats, so we are really supporting a large variety of data formats. As I said, we are supporting raw data, and this is very, very unique. So we built our own converter technology for multi-beam data sets, for side scan, for sub-bottom, for seismic. But we are also incorporating the classical raster and vector data like shapefiles, geodatabases, like geotiffs and other formats, for example, from the world of point clouds. So, but you will see some of the examples later in the presentation by Simon. And I'm giving you here directly the next one over. So Simon is now giving you actually a demonstration. It's a very demonstration about focusing on data management and some of the first features that we would like to give you. But happy, Simon, to share now actually the demonstration, and looking forward to the feedback and the QA session and sneak peek actually into where we are heading in the future as well.
Beautiful. Thank you, Jan. And let me please take over and also take the screen off you. You should be able to see the screen. Yeah, that's confirmed. Good. My name is Simon van der Wulp. I'm the solution engineer. I am working with the product, making sure that all the requirements that we set for this application also actually come into the application and that we can work with it. And I would like to give you a short run through the system to show you the highlights of what we have on the level of data management and the collaboration features that we have in there. And then we have to sort of go to the perspective of that you will be our customer and have got your own dedicated platform, which you can use to run your data on. Now, how is the platform set up? The data platform, the TrueOcean data platform, has got individual projects which you can organize your data in. That means anyone on the platform can create projects in terms of a wind park collaboration or like a wind park development, or you've got certain data which you like to receive from one of your contractors. It's all organized in these individual projects. Now, what's really nice with these projects, being of course cloud-based, web-based, is that anyone can access it from anywhere in the world at any time. Yeah? Okay, then how do you manage the access to these platforms? Everything is secure. People need to be invited. People need to authenticate. People need to provide their passwords. For this, we've got 3 different roles, as you say. So we've got the administrators who can sort of manage the platform internally. And of course, you can invite many colleagues as members. But if you have, for example, also external people which you'd like to bring in for a short collaboration or a partial collaboration within a project, you can simply invite them. You can even set a date out. So for example, if we invite users on the platform, you can invite guests and set a certain expiry date, like, look, for this month, this person can be there, and he then will be able to access the platform. Not just access and see everything, it can be completely individualized. That means you can bring this guest to an individual project. So if we go to the project list here, then in the project, you can completely dedicate who you would like to add. So for example, here, the guest, which is the other user that we have, we can invite him. Now this person is brought into the project. Does this mean that he can straight away see the entire project? You might want to have it. Certain customers of us, they say, for example, we just want to give him access to only a part of the project. You can completely individualize this. So, talking about the projects, let's have a look into one. I've got this wind park project prepared. Now, what you see here is basically what you're also used to from a common cloud. You see files. On the top, files in a file tree in folders with the individual files put into them, nothing new there. The project also has an information tab where you can give a short description, you can set the project name, all to maybe communicate with the collaborators of what this project is about. But still going back to the files. These files can be anything. It can be your documents, it can be your images, it can be videos, but of course also your data. How do we upload them? If you would like to upload your data, you can simply say, look, I want to upload, and you get the offer to do it via a browser, mostly limited to just smaller amounts of data. But the big advantage is that we also provide other protocols, like for example SFTP or rsync, which can allow you to upload larger quantities. Basically what we do here, we create a special SFTP server for you, and then you can access this with the credentials provided. If you wait a few seconds, it will be prepared and shown here. There we have it. So you will get these credentials, and you, or maybe also somebody from external, can simply use these credentials to upload the data on this SFTP server. Once you're done, you simply say sync, you confirm, and the data will be then merged within this list that you have here. If we then go into the individual files, as said, it has certain features with common cloud perspectives. So for example, if you have a report, it's like for example, daily reports which you get from the field, you can have a look there, and the PDFs are simply accessible. Same as, for example, images and videos. I can take a small video here and simply select them. They're accessible, you can download them, but you can also preview them. Of course, it has to shortly load. And then you can basically run it down for the very basic functionalities. Yeah. Of course, these are very generic file formats, but actually what we're interested in, and what also Jan also mentioned, is we are interested in the marine data. So everything we get from the sensors, all the spatial formats, so the common generic GIS formats, but also the multi-beams, the side-scan sonars, the subatom profiling, etc. To give you a short preview in what we do there, I can, for example, start very basic with a shapefile that we have. So a shapefile, it's uploaded, it's straight away recognized as a shapefile and also straight away previewed as a shapefile. No need for an extra GIS system, no need maybe for somebody who is not familiar with GIS systems. They can straight away preview it, they can straight away see what's in there. Now, what do we do with these spatial files in general? This is also like the normal GIS files, but also the sensor files, is we index them. So what we do, we take these files, and once they're uploaded, we have a peek inside. We look what's in the file, what kind of type is it, what are the previews, where is it located in the world, and of course, if we talk about creating previews, we already work with your file to create certain previews, which you then straight away gives you an insight in what is in the file, for example, for QA purposes or completion of the content. So this indexing also allows you to later on to find your files geographically, meaning that, for example, if you upload legacy data, you might not really know what's exactly in those files, rerun them through, and we make them searchable on your map. I'll get back to that a bit later. So here we've got, for example, to run you through a couple of examples, a simple shapefile, but we also got rasters, like a common geotiff. They're straight away visible, straight away recognizable, and ready for inspection. If we then go a bit deeper, for example, in the multi-beam data, we get the raw data, for example, XTFs. We can click the files, and what we do there, we analyze the file on different levels. That means we make sure that we first show you the coverage. What kind of area does it cover? What's the track that is gone? We've got the metadata shown, so anything that's written in the headers is shown there, like sensor types, etc. Yeah? Then we can show the different tables, and I have to see if the 3D preview comes down. This runs down, and here you also see a 3D preview straight away available, so you can actually inspect the data itself. We've got different 3D previewers. We've got, for example, also another one, like for example, this PTS, which gives you, for example, also this view. That means there's different views available to watch the different files. Yeah. So if we've got multi-beam covered here, a PTS file, for example, we can also go into other types of data, for example, the subatom profiling. Also here, the first step is that we bring this on the map. We show you where the ship actually has gone, where it took the information. And here we're talking about the North Sea, the German North Sea, where this data has been collected. And also here, the same thing. We check in the headers, we see what kind of metadata is available. We extract data with a peek preview of the table, just for you to check what kind of headers are in there, what kind of numbers. But also there, we go a bit further, we look into the data, and we already provide you a preview for quick assessment if the data tells you what you would expect from this. Otherwise, we also have, for example, the side scan sonar data. Here it's a bit more tricky because here there's a bit more processing involved, which already touches a bit that what Jan also mentioned beforehand, talking about the big data processing, that we actually take the file, we start computing with it, we start calculating with it, for example, to rasterize the image and get a decent preview. Again, here you know where it is, you know the coverage, we got the metadata, a table can be provided, and the preview is then shown in a bit of a different format, in a GeoTIFF format, showing basically where it lies. Yeah? We're also still working on advanced ways to process the data more and clean it up in a nice way that the side scan sonar does what it should give you. Certain files also might have some issues. For example, a coordinate reference system is not provided or any of such. And here we also provide the option to analyze, and if we find an issue, we can straight away indicate this, meaning, oh, we're not able to process the file, this or that could be missing, please check the file, or maybe even we provide you with solutions in the near future. So this is a bit of a demonstration of what we can actually show there. Then we would go to the sharing part, because maybe you've tracked the whole process, you've collected the data, in the end you've got some deliverables, like this is, for example, a GeoTIFF, which we got here set up, 1.8 gigabytes. Let's say we've got this as a ready-made, like a data product in the end, and you would like to share this with your colleagues, with your partners, with contractors, whatever. So this way we can then provide you with some sharing. So if you share it, we again offer different ways to do so. We can say, okay, we have got the SFTP and the rsync, just like the uploading, but then of course in the other way. We put the data on an SFTP server, and there you have it. You can also, if it's within a certain bound, provide you with a link, which is for this we then have got a zip file prepared for you. And if you then get it, anyone who gets this link then gets the option to download this. So be aware with sharing the link, of course, but this would expose it. Also has an expiry date, and of course you can close it at any time. If you say that you wouldn't like to share, but you'd rather work with it internally, for example, in a GIS system, we also offer the options to share the individual files as WMS. So if you say share WMS, let me quickly go back there, or manage the WMS, it creates this link for you, and if you take the link, you can take it into a GIS system. For example, let me quickly go to the right. Here I've got, for example, QGIS opened. Here you've got the URL set, and of course I don't have to explain you how WMS works, but you can actually bring this information to the map. Of course, let me take the link there and edit the connection. We've got this, we've got this. Okay, that's of course then the preview effect. So I'll keep a rain check on that with you for now. And additionally, we can also make sure that these files, for example, if you're not working with the GIS system, but you would like to work with another map, we also provide then the different maps that we have on the platform itself. So the individual projects allow you to save the data, to work with the data, to manage the data. And if you would like to have something, maps which you can collaborate with, then of course we got the map section. So from the projects, we turn into the maps. And here, any user can can create individual maps. So if you would like to have a map to work on for yourself, put certain data from one or from multiple projects on, you can simply create a map, and with this map you can rename it, and you can also invite people there. So for example, I've got the map prepared here for the BSH, and if I say I'd like to work with Jan together, but also the guest I have on the platform, then I can simply invite them. Now this person can also see the map, or if you're really interested, you can also give them an extra access by allowing them to edit the map as well. So what does the map offer? It offers you a collaboration platform where you both see the same map. So it's a bit taken away from the GIS and more on a collaborative scale that multiple people can look at the same map simultaneously. It works comparable to what a normal GIS provides. We can add individual files. For example, if I say here, I would like to add another layer, you get presented with all the projects you've got access to, and from there you can select data, for example here from our project, and we create, for example, this XDF, and we can add it to the map, and with a bit of patience it will simply appear on the map, and there you can work with this. It has the vector data, it has the individual raster data supported, and it shows you in the end the data which you have inside of your projects. Now there's a couple of other features on the maps which can be very helpful. At first, you've got the option to make basic measurements, a length measurement, or a surface area measurement, radius measurements, small, simple tool. What we also provide, if it's, for example, used for the surveying itself, we can provide a little weather forecast provided by Spire, which is something we connect to, and then we get you the weather forecast, or also current speeds and wave heights if you need them. As mentioned before, we treat these files in a bit of a special way, so the Trojan platform is allowed to index, or is able to index your spatial files, meaning that we know where they are. So if you're looking for a certain file, maybe from a project from a couple of years ago, and you don't really know which folder was it, which file, what was the code that we used in the file name, if you're not aware of what's, let's say, in the project, but still you'd like to find something, then we provide you with a GeoSearch. We quickly add this here. So with the GeoSearch, you can click on the map, you can select a given area, and of course, we have to look through all your projects, so it's a process which takes a bit, but in this meantime, you would be opening your browser, looking for the files, going like, okay, what folder, what directory was it in again? And while we do this, we simply let the GeoSearch roll, let it do its work. And with the results also, we can, if we have the results, we can search, we can select by projects, we can filter by file type, we can filter by data type. And then if we say, wait, here I've got this file I was looking for, you can simply add it to the map, or even you can open it in the project and you're straight away brought to the location where this file is located, meaning that you can find any data in any project from within the map. You simply use the GeoSearch and then you have it. Going back to the map, those are more or less the features which are in there, and that would more or less conclude me. I've got one more thing which I have to add there. For example, we've got certain customers who've got their own computer system, their own let's say backend, their own system which they store data on. and sometimes they would like to maybe show the progress of a survey. So what they do is they expose a WMS service themselves, and these WMS services can also be used here. That means that if you would have a WMS service being a nautical map or being a progress of your own surveys, for example, you can provide these links, and if you add that link to the platform, you can connect, and there you can simply choose what you would like to add and simply add them to the map. Let's take, for example, the telecommunications there, and it's straight away there. So that means the platform doesn't stand on its own. It can also consume externally information which you might want to use for your work. Yeah, I said too much to tell, too little time. I would like to conclude this run through here, and I'd like to hand over back to Jan to tell us a bit more about the outlooks that we have.
Perfect. Thank you very much, Simon, for the presentation. So Natalia is already giving me again the sharing opportunity. But before we tell you where we are heading, what we are still doing, we would like to do a Q&A with you. So maybe there are already now some questions that you would like to expose right here. So Natalia is actually all the time monitoring the feed. And Natalia, maybe you have something for us.
Yes, thank you both. We've got a few questions from our attendees. First one is, can you really work with raw sensor data formats?
Yeah,
Who
I think
would
that's
like to take it?
there, I will directly take it. So I think that's one of the USPs of our technology. Yeah. So as Simon already stated and showed, he showed this one example of an XTF of a multi-beam, but this is where we see the future in. Yeah. So we don't want to work with a data product in a special hydrographic software suite, actually run it through another specialist, running it again into another system. So we would like to take the complexity out of this world. And this is what we are actually doing with the technology that we are providing. The first thing is, as soon as you're pushing some raw data in, we are geo-indexing it. And Simon showed it. I think that's a totally unique approach. Yeah? So it's automatically, we read the file, we compute with very sophisticated algorithms, the sensor coverage, and already this is of highest value to know actually, did the surveyor in the end provide you the information that you need? And it leads you actually to the idea of being able to search for data. Yeah, going through petabytes of your data versus going through Excel lists, NIS shares or whatever. So it's a new approach, a new way of how we think about actually also ocean data. And also, Natalia, so to add to this question, we will also, and we are using this already for compute. Yeah, because that's what I mentioned actually in the second pyramid diagram, that we are already taking this data, this raw data, and using this for compute actually the geotiffs, for example, in the side scan sonar case that Simon just mentioned. Yeah, so we take the raw data, we run the automated corrections, we push out a geotiff, and you can directly consume it via a web map service in minutes. Yeah, so taking lots of actually overhead out, taking also some more specialists actually, so assign them to other tasks. So I think it provides a big possibility for enhancing workflows.
Thanks, Jan. We got another question, quite specific. It says, can you make edits or changes to the data in the maps or previews and the platform overall, or is this just for storage, viewing, and sharing?
Yeah, very good question. So maybe I also overtake it, Simon, maybe you can add. So the most important part is now that we are supporting with the platform the reading and sharing and collaboration. But we are already working on the ability to edit the files. Yeah, so adding metadata, so adding and editing metadata, very important part of it. We will introduce actually in the next quarter the whole topic of full coordinate reference system support. Yeah, so you can actually add the coordinate reference systems. It's directly saved, and so it's directly on the roadmap. We will be there at the end of the quarter, adding more and more functionality on top of this. But the base for this is for sure reading the files, and on top of this, adding will come at a later stage in the flow.
Okay, thank you. Another one, how do you see the future and applications of big data technology in this field? Maybe a bit more for Jan.
Yeah, probably also. So where is this whole approach heading? Yeah, so we see that the amount of data is growing and growing and growing, and the complexity with it is growing. So you need many specialists. You are creating a huge overhead by having multiple desktop systems for all this kind of processing. We honestly don't see desktop as the future. And I think you see this already in other domains that cloud is overtaking, because cloud, whatever cloud you define, it can be a computing center in your private entity, it can be a public provider like Amazon or whatever, but they deliver us totally new possibilities, also in terms of processing, because we know this data is getting bigger, it's getting more complex to handle. So just the process of doing for every stripe the whole correction manually in a desktop software suite, taking all these stripes, trying to merge it in some GDAL, QGIS, ArcGIS ways, outputting it as a web map service, for example, for really working on it. We need to automatize this. Yeah, so with the amount of projects that are upcoming in the future, about the complexity that is coming with this data, automation is the key. Cloud is also the key to this, because it needs compute. That's a very important part. Yeah? And we also need to understand the raw data for it, not just the pure data products, but really start with the sensor data level.
Okay, thank you. Another one. How survey dataset versions are managed between preliminary without QC and final, and are they linked to corresponding revision of report?
Very interesting question. So I think it's not the first time that we hear this question. So versioning of files. I think all of us know we're in the field of GIS, test version 1, test version 2, beta, final 1, final 2. So we are right now addressing this topic with 2 customers who are giving us information about conceptualization of how this can look like, also in terms of revision and things. For sure, you can do for today the classical way of just naming it, but this is not where the future is heading. We want to make this smarter. And exactly this kind of functionality is just in the conceptualization phase, and we will bring it very soon on the roadmap, how to work with revisions on these files, because it's one of the biggest complexities also in the domain. But we have some very interesting ideas, and we are happy to discuss with the person who asked this question, also to discuss this more in detail as well.
Very nice. Okay, we are running a bit out of time, but I think we still have time for a couple more questions. Is it possible to visualize both vector and raster data on the same view in your platform?
Yeah, that's possible. I mean, you saw it, what Simon did. So vector data in different kinds of formats that we support. We even support the proprietary geodatabases of ArcGIS. We saw the classical TIFFs, GeoTIFFs, TIFFs with world files, JPEGs, PNGs with world files. We can either actually stream both out, so we can also stream vector data out at web map service, so we can push it into other systems, but we can also directly overlay this information. And this is what customers, for example, doing already to assess the survey actually status. Yeah, to get actually this data in, check it together with the information that needs to be provided to assess the quality of the survey and the progress of the survey. But that's definitely the case. So vector and raster, honestly, that's the easier part. The more complexity comes with a raw sensor. If you are dealing with raw sensor, you can definitely deal with raster and vector, because that's where data is getting big. But still, big raster data, also a complexity to handle, but we found some very smart optimization ways to do this in an automated fashion.
Okay, last one, I would say. We are a renewable energies developer, including offshore projects. We already have a GIS system and an internal server for geodata storage. Would you say that TrueOcean should be replacing our offshore geodata storage or complementing, working alongside our existing storage? Very good question.
Very, very good question. So, I mean, there are different strategies, and our customers are doing different strategies. Yeah. So, I mean, when you talk about big data, and we all know that the data which is getting in also during the future maintenance operation phase is getting bigger and bigger. Cloud provides you the easier ability to scale. We all the time for sure discuss also with your in-house IT departments how to do it best. And for sure, it depends on also your company policy in this. But with most of your colleagues that we are addressing this kind of topics, we are coming to the conclusion that the Ocean Data Platform is a perfect addition to the existing data set, and that partially data is already migrated. We are working, for example, now on a very cheap archiving way, so having archived data in the platform as well. So this is as cheap and as comparable as possible. But maybe, Natalia, let me take this and show the last 2 slides, because it leads already to the conclusions. Yeah. So thank you very much for the questions. Happy to discuss this further, but would like to give you the summary and also actually some offer from our side. So as we hopefully showed, TrueOcean really has the idea of introducing a new paradigm of how we deal with ocean data. Yeah. On the one side, it's really collaboration in web-based, cloud-based environments, how to optimize actually this collaboration, the workflows, and how to in the end save you money and save you time and complexity. We, as a USP, and this is very clear, utilize raw sensor data, which is the highest level of data that you can get. It's important for decision making. It is the future of running AI on this kind of data as well. This one, Natalia, what you just mentioned, or I just mentioned, actually, we can be seamlessly integrated into existing infrastructures, also geospatial infrastructures. Yeah? So we provide, for example, APIs. The GeoSearch that Simon showed, you can simply send an API request to the GeoSearch and take from this a web map service and implement it into your existing solutions. Yeah? So a very cool way of integrating the back-end technology of ours into big geospatial data infrastructures. We provide these data sharing protocols, which are standard. Yeah? So you can use the standard data sharing protocols when working together in collaborative environments. We provide web map and web feature service, which is a standardized OGC approach in our geodata world. So there are very, very many ways of how we can do a specific solution for you, because for sure there are IT departments involved, there are management departments involved, there are strategic decisions involved. But with all our customers, we found very good solutions of how to integrate into your existing systems. What we also would like to already announce here, with our technology, we are running into an early mover advantage regarding, for example, the legal developments on the European level regarding cybersecurity and critical infrastructure protection like NIS2 and CRE. Because this is something that you as organizations will face, especially in the offshore wind domain, because you are running critical infrastructure, and our technology is already going in the direction of supporting and helping in this kind of field. Yeah, and last but not least, I would like to introduce my colleague Philip, who is actually our go-to guy in terms of our offer, what we would like to offer you. So we would like to offer you to upload your sample data. So what we do usually when we start with a new customer, they upload sample data via a secure private environment, via SFTP, via FTP share, and we directly look at it. We create a personalized data report to see, is your data already supported in our environments? Very probable it is. So we are getting better. We even have more formats on the list, but we already have a very, very good format support. We provide you with a personalized data report for every organization and department, specifically for your data to assess this kind of information. And then for sure, you have the ability to test your platform yourself. So you can receive, if you are contacting us and if you would like to discuss further, free of charge private deployment in our platform, which is fully supported by our solution engineering team, for example, Simon and our colleagues, to find the best way for you and your organization and your specific needs. Because every organization is specific, that's clear, but we provide lots of possibilities of supporting individual ways actually of workflow optimization of organizations' implementation of our technology. And I think, Natalia, we are almost perfect in time. So thank you very much, actually, everyone, for joining this webinar. We will do more of this, also addressing different kind of topics, different kind of technologies in our platform. And we are really looking forward to get in contact with you, showing you our technology and getting to test it with your environment and your data. So thank you very much for your time and your patience.
Thank you, everyone. Hope you enjoyed the session. Bye-bye. See you next time.
Bye-bye.